Hey everyone, and welcome back to our latest explainer. So today we're focusing on something you're using at this exact second, but it rarely gets the conscious appreciation it actually deserves. We're looking at the human heart. But we aren't just going to look at it as a regular organ. No, we're breaking it down as the ultimate biological machine. It's literally a tirelessly working engine right there deep inside your chest, keeping the whole show running. We're going to dive into its mechanics, its structure, and of course, how to properly maintain it.
To really wrap our heads around the scale of what we're dealing with here, 100,000. That's the number of times this incredibly powerful engine beats in a single day. I mean, just think about that for a second. Over 100,000 times every single day, and you don't even have to press a start button or plug it into a charger. It's an absolutely extraordinary biological feat, and it sets the perfect stage for everything we're about to explore.
Okay, let's dive right into this. Section 1. The body's ultimate engine. Stationed diagonally right there in the center console of your chest, this special muscle is ready to do its job. So, what exactly is that job? Well, at its core, it's a biological pump. Think about one of those manual pumps you'd use to inflate your bicycle tires. When you push down on that handle, you're forcing air into a confined space, right? The heart operates on that exact same mechanical principle. The only difference is, instead of pumping air, it's pumping blood. And this blood is the absolute lifeline for our bodies. By forcefully pumping this fluid, the heart is delivering life-giving oxygen and all those essential nutrients to every single cell we have.
Moving on to Section 2, inside the heart's anatomy. Let's get right into the mechanical breakdown.
Let's start with the basic layout. When we compare the right part and the left part of the heart, the really crucial thing to grasp here is that these two halves are completely separated by a solid cellular wall, like they are entirely divided. The fuel on the right side does not mix internally with the fuel on the left side. No way. It's this super elegant design choice that ensures the whole machine runs at peak efficiency without, crossing its wires, so to speak.
Now, what's really interesting about this setup is how each of those divided halves is broken down even further. We've got upper cavities and lower cavities, which gives us 4 distinct chambers in total. The upper ones are what we call the right and left atrium, and right below them, the lower cavities are the right and left ventricle. Basically, these 4 rooms are where the blood hangs out and gets pressurized before it's pushed along to the next step of the journey.
And hey, if you have distinct rooms, you obviously need doors between them, right? That brings us to the next big component, the valves. The heart has 4 of these doors acting as absolute mechanical checkpoints, and they have one very specific, incredibly important job. They pop open to let the blood in, and then snap. They shut tightly to make sure that blood absolutely cannot flow backward. It is a strictly one-way street. These one-way doors are what keeps the engine's fluid constantly moving forward, keeping that pressure and efficiency exactly where it needs to be.
All right, Section 3, the journey of blood. Let's trace how the fuel actually moves.
So, we've got the chambers and we've got the doors. Let's trace the actual route. The cycle kicks off when deoxygenated blood, meaning blood that's already dropped off its payload and is running on empty, enters the heart right into that right atrium. From there, it drops through the first valve down into the right ventricle. Step 2, boom, the heart forcefully launches this blood straight to the lungs. Think of this as the ultimate pit stop. In the lungs, the blood gets oxygenated, filling right back up on fresh oxygen and nutrients. Step 3, this newly supercharged blood travels back to the heart, landing in the left atrium. It slips through the 3rd valve into our final cavity, the left ventricle. And then, Step 4, the heart gives this massive pump, blasting that rich oxygenated blood out through the 4th and final valve, sending it all the way out to the rest of the body. And the crazy part? The cycle instantly starts all over again.
And this brilliantly illustrates the sheer mechanical simplicity behind all that complex biology. To really lock this concept into your brain, try this analogy. Just imagine your own hand as the heart. When you open your hand up, stretching your fingers wide, imagine that space filling up with fluid. Then, when you tightly clench your fists closed, you're forcefully squeezing and pumping that fluid outward. That simple opening and closing, expanding and contracting, that is the fundamental physical action driving your life every single second of the day.
Moving right along to Section 4, your body's highway system.
So the crucial point here is understanding exactly how this massive highway network is organized. Because when the blood exits the heart, it's flowing through 3 distinct types of blood vessels. First up, the arteries. Their main gig is outbound delivery. They carry that oxygen and nutrient-rich blood away from the heart and out to all the organs. Next, we have the veins. These are the return routes. They gather up that blood, which is now low on oxygen, and ferry it all the way back to the heart to restart the whole cycle. And finally, we have the capillaries.
You can think of these as the intricate, tiny little side streets that bridge the gap between the arteries and the veins. They make sure the fuel reaches its exact final destination right down at the cellular level.
Let's move to see how this builds into our everyday lives with Section 5, Taking Care of Your Heart, the Owner's Manual.
Now, before we hit the actual maintenance rules, I've got to share this really fascinating physical spec with you. 450. That is how much the average human heart weighs in grams. Meaning, this tireless pump that's working for you day and night is practically half a kilo of pure, incredibly strong muscle. For its size, it is an absolute powerhouse.
And knowing it's this half-kilo block of high-performance muscle, we really need to treat it like one. The source material lays out 3 absolutely non-negotiable rules for your personal owner's manual. First, you've got to get physical exercise to keep that muscle toned and efficient. Second, you have to fuel the machine properly by eating healthy foods. And third, and guys, this is heavily emphasized in our source text as the absolute worst thing you could possibly do to hurt your heart, never ever smoke. Protecting your circulatory engine means completely avoiding the toxins that directly degrade its mechanics and completely trash its highway system.
Which brings us to our final takeaway for this explainer. Think about that incredible 450-gram biological machine sitting just left of the center of your chest. Are you giving it the premium care it actually needs to successfully beat another 100,000 times tomorrow? I mean, it's a question definitely worth asking yourself every time you choose what to eat, whether or not to exercise, and just generally how you live your daily life. Take care of your engine, and I promise you, it will take care of you. Thanks so much for joining me to explore this incredible topic today. I encourage you to keep learning and keep asking those great questions about the amazing mechanics of the world around us.